So polynomial functions is what we're looking at today. And the biggest thing for this one is it's kind of backing up and doing some things that we already know. So again, nothing really, there's one kind of new thing we've got to do, but even that one is basically just looking at the chart. Just remember, when we're talking about a lot of the polynomial functions on this, we're going to be talking about the terms and the amount of terms and how the terms are set up for this part. Just remember, terms are separated by a plus or a minus. And just remember that each term has a different variable power. And that kind of comes back when we're doing the full method, when we're doing combining like terms, we're doing all those things. You know, we always talk about combining like terms on that part of it. And again, it's just remembering that if we're counting up how many, different terms, the way the terms are arranged for that part of, just remember that the pluses and minuses always separate out the different terms that we're looking for. Okay, and when we're classifying terms, basically we've got two big ways we're going to look at these. We're going to name it first by the number of terms. Again, not anything new for this part. It's stuff that you've heard before, so we're not going to do anything that's mind-blowing here. All right, so they give you an expression, and if that expression has one term, it's called a monomial. Sometimes if you're looking at your speaker settings, sometimes they'll talk about something being in mono as opposed to being in stereo. So stereo is both sides of the speakers working. If it's mono, it's only one side. So that's usually what we're talking about. If you're talking about this one, and for an example of something like this, this would be where you have something like 4x squared. All right, if you have two terms, it's a binomial, because again, bicycle, anything like that, it's always got two with it. If you're looking at something like that, that's a lot of the equations that we had when we're working with graphing. Y equals mx plus b form. That with the mx plus b, that's a binomial because you've got two different terms that's there. All right, and if two terms is a binomial, three terms is a trinomial. All right. That's a lot of the quadratic equations that we look at. We have something like that where we've got x squared plus 5x minus 10. Okay, and those are the only three that have a very specific name. Everything else after that, if you have greater than three terms, so we're talking. So a lot of times they'll say this where you've got n greater than three terms, where n is your number of terms. If it's four terms, or five terms, or six terms, or seven or eight terms, whatever it's going to be called, basically it's just called a n-term polynomial. So if we happen to be, so if we're doing factor by grouping, we had four terms, they just call it a four-term polynomial. There's no special name for if it's got four terms. 1, 2, 3 terms, we've got all those. But four terms, it's just a four-term polynomial. Five terms, it's a five-term polynomial. Okay. Now, one other thing we talked about a little bit, I think, in some of these things that we're talking about, and why they wait this long to talk about this, I don't know. That's why we've already talked about it a little bit before this one. But they talk about the degree. That is the highest power of a, they have to give you a specific variable because sometimes they may give you two or three variables. So they'll have to give you, if most of the time we're talking about x, So we'll just say this is the highest power of a specific or some specified variable. Okay, and where we've kind of talked about this a little bit is that if you have the degree, that's going to equal your number of solutions. So when we were solving equations, we were factoring. We talked about that. If it's got x to the third, you're going to have 3 answers. If it's x squared, you're looking for 2 answers. So that's where one of those things where we've already talked about a little bit, but this is one where they kind of go back and mention it again. That okay, based on your degree, that tells you how many different solutions that you're going to be looking for. Okay. So the other way we're going to classify these things is we're going to name it by degree. So we're naming it by the number of terms, whether it's 1, 2, 3, or just an n-term polynomial. The other way, again, is we're going to name it by degree. So for this one, we're going to make a little T-chart here. Okay, so we're going to give you a degree, we're going to name it, and then we're also going to show an example of how this thing is going to look. And same thing with these. We're not going to give you everything. We'll just give you like the most important ones that we're going to look at as we go through everything here. So, okay, so if we're naming these by degrees, we're going to start off with something that's to the 0 power. Okay, if it's the 0 power, basically anything to the 0 power, the answer would be 1. So in this case, we're going to say this thing would be a constant. All right, and the way we're going to set this thing up is we're going to give it to you in an equation form instead of just an expression. So for something like this would be y equals 4. Where there is no power of x that we're looking for this one. Okay, so when we're talking about everything for these examples, we're going to use x for a variable just because that's how it's going to go. So we're going to look at the power of x for these equations or these expressions that we go through. All right, something is degree 1. Think back to when we were graphing equations. If it was, 2x minus 5, that would be x to the first power. And if we graph that, that would look like a line. So that means it's a linear equation. All right, so degree 2. Think about all the graphs that we just got finished doing. Those were what kind of graphs? Yeah, quadratics. So that's x squared minus 13x, plus 7 or something like that. Now somebody's asking, well, I thought quad means 4. It does. For some reason, in this case, it's 2. I don't know why they kind of. I'm sure that came from a different language that had a different set of numbers and how it was set up for this part of it. But yeah, so normally quad you think 4, but in this case quadratic we're thinking it's 2 because we use the quadratic equation, the quadratic formula, all those things that we've got. Something's degree 2. There's our degree 2 that's up here. In that case, this would be understood 1 that would be here, so that's where we got our first power. Okay, what about something to the third power? Y'all, anybody remember that one? Okay, so you got your x to the third power, how this thing is set up. And again, it could just be, it doesn't matter necessarily how many terms it has, but the main thing is your highest power is x to the third. So what if you take something to the third power? What's another way you could say that? Anybody remember? Cube? Yeah. So if you take something to the third power, that's cubed. So that's going to be a cubic. To me, 2 should have been squared. I don't know if you call it squaric or not, but cube is cubic, square would be square, but they go quadratic in this case. All right, something to the fourth power. And this one kind of, if you think about it, if we take quad out, because we know quad's already taken care of, what's something else that you have 4 of a lot? Oh, yeah, get in there. Think about something, you split something into fours. Take money, take $1, you split it into fours. You get 4 quarters, you get 4 quarts in a gallon. So with 4, yeah, it's going to be quartic. Could be a quartet. There you go. All right, and then the last one that we worry about is x to the 5th power. And this is where it ties in with a little bit of, and again, we don't think about this one a lot, the way it's set up, but this one is quintic. It's close to what? 15. All right, and then standard form, which again, y'all know this one. Yep. Okay, so for standard form, you're going to write the terms in descending order. Again, based on the powers of the specified variable. Again, most of our cases, we're going to be talking about x in this case. Occasionally, if they happen to throw a different variable, you would kind of go on that one. So just write the terms in descending order based on the powers of the specified variable. Okay. And as you do these, the one thing you have to kind of have for this part of it is the first term is always kind of the most important term, because y'all remember when we were graphing, the first term told us the direction the graph was going to go. If we were factoring, we went to the first term to see how many, what it was going to be set up, whether it was a value was 1 or a value wasn't 1. So the first term in all these cases is always really the key thing that we're going for. So the first term in standard form has what they call the leading coefficient. Okay, and we'll talk more about the leading coefficient here in just a minute, but we got one other thing we got to do before we get back to that part. Okay, so what we're going to do for this, we'll give you a few examples here where we're going to ask you to kind of put all those things together that we've done so far. We're going to give you an expression. You've got to write the expression in standard form. Based on that answer, you got to tell me by degree what's the degree of it going to be, and then how many terms that you have based on that part. And it will kind of go back and forth. We'll kind of mention all the possibilities, because it could be that they may ask you for just the number. So like 1, 2, 3 terms. It may also ask for monomial, binomial, trinomial, that kind of thing. So we'll show you both options of answers when it goes off this part. Okay, so there's our first example. 3x to the third minus x plus, and then 5x to the fourth. The big thing when you're doing these, and again, you don't have to do this every time, just making sure that you've got these, that whenever you're going to move the terms around when you go through these, I always say you start with the back expression, the back term, and make sure when you're doing this one that whenever you move these around, that sign will always go with the 5x to the fourth. The minus will always go with the x, and the 3x to the third, if that's not the leading term, then basically we know that thing would have a plus that's in front of it there. Okay, so we're going to start with 5x to the fourth. Again, if we put it in descending order based on the powers of x, x to the third is our next term, so it's a plus 3x to the third. There is no x squared term, then we have a minus x. Okay, and and again, nothing really new on that one. That's standard form. That's pretty much stuff that y'all have done for quite a while now, so there's not really anything new on that one. Okay. So then from there, we're going to classify it by degree, which again is your highest power. So in this case, degree is 4. And if it's degree 4, they may let you say degree 4. They may also say what is that name as far as what it goes. That would be quartic. So again, it may do this sometimes. Sometimes it can be a drop down menu where you pick those. It may just let you type in what you have there. Okay, and really it comes down to, when you've got your terms here, we've got these going for this part of it, so that would make it 3 terms. Again, if we name it by an actual specific name, that would make it a trinomial. All right, everybody good at that so far? Nothing too crazy. Okay, so for example 2, we're going to go 3 minus 4x squared plus 5x and then minus 10x to the third. All right, and again, if you ever get a little confused on these, because most time everybody's pretty straightforward, but again, if you have to kind of break it down, just remember that as you're moving these around, the minus goes with the 10x to the third, the plus would go with the 5x. You got your minus 4x squared. Again, the 3 would be there, and if there's not a sign there, then obviously that would make that a plus. Okay, the other thing of doing that one is, as soon as you do that, it also lets you know how many terms that you're looking for. So we've got x to the third, x squared, x in that one. So right off the bat, we can see that we've got 4 terms. And again, if it's 4 terms with it, they'll just say it's a 4-term polynomial. So there's really not a specific name on that one. So that's pretty much all they can do is just say that it's 4 terms. Starting with our highest power of x, in this case, would be x to the third. It's negative 10x to the third. It's a minus 4x squared, a plus 5x, and then a plus 3. All right, so there's our standard form. All right, and by degree, highest power, so degree equals 3, which again, they may also throw it as degree 3. They may also just say that in this case it's going to be cubic. Okay, and about the only thing they can do to make it a trick question on one of these. Let me take this to the next page. Everybody good there? Okay, so only example here, like, again, I can think of that would give you any kind of a something to pause to make you go just a little bit. Would be one where if you had something like this. All right, so again, if you kind of separate it by terms, we know the plus goes with the 12, that plus goes with the 5x squared, that plus will go with the 10, that minus will go with the 16x. Okay. And if you go back and rewrite it in standard form, you've got your 5x squared minus 16x. And then you get down to the 10 and the 12, and you're like, well, hey, I've got two like terms in this case. Yep. So if you've got like terms, you go ahead and just combine those like terms together and make that 22. So in the beginning, what looks like it's got 4 terms actually really only has 3 terms because you can combine a couple of the like terms together to get through this thing. So there's our standard form. If we name it by degree, so degree is 2, which again may be what they're going to call quadratic because we can kind of go either route there. And if we name it by terms, we've got 1, 2, 3 terms, which means it could be a trinomial. Okay, so that's it. I mean, as far as trick questions, that's the only thing trick question wise that you really would look at as far as it comes down to. Okay, and then the last, now we didn't talk anything about the leading coefficient back here. So this is where we're going to come back and talk about, because we got all the other stuff here, all the different powers on this one. Here's where we talk about the leading coefficient on this thing. And this is something new that I'm 99% sure y'all would not have talked about this back in Algebra 1. So this is one just kind of hang with me a little bit here for this one. So. All right, so for this one, we're talking about end behaviors of graphs. And again, where this ties in with this part of it is that with everything we're doing on this one, this is based on the leading term when an expression is written in standard form. Actually, I should have said leading term, my bad. I mean, if you got leading coefficient, just put leading term here at the end. So the leading coefficient is just the number. When we talk about the leading term or the leading coefficient with that one, it's basically, it's the whole thing. It's not just the number. It's kind of everything that we're looking at for this part. All right, so here's where you get to make a little, it's almost like a kind of, it's like a tic-tac-toe box, but it's just off a little bit. So everything being equal, it's kind of Just need a small box up here, and then big boxes over here. All right, that may be a little bit overkill, but it'll be okay. Okay, so again, for this part, we're on now, and we'll actually get into this is just the ends of the graph. Everything that happens in the middle, we'll talk about that more in the next sections that's coming up a little bit later on. But right now, we're just worried about what's happening on the ends of the graph, because we'll come back and talk about all the stuff that's happening in the middle of it. So for that one, you're always going to go back to your leading term. Again, we're assuming it's going to be written in standard form so we can get the leading term really easily on this thing. And based on that leading term, it's one of two things. It's either going to be a positive number or it's going to be a negative number. Because that's only, it's somebody like, what about zero? It won't be zero, because if it's zero, it's going to be 0 times something, which would make it 0, which it wouldn't be the leading term, because it needs to be something else other than just a 0 that's in there. It needs to have a power to it when we're looking at this thing. All right, and for your degrees, it's basically one of two things. It's either an even degree or it's odd. Yeah. And when we're doing something with the even degree, x to the second, x to the fourth, x to the sixth, x to the eighth, doesn't matter what it is. If it's something to an even power, you've got to think like it's x squared, because we know what the graph of x squared looks like. And all the other graphs, if it's x to the second, x to the fourth, x to the sixth, x to the eighth, everything else after that is going to look similar to x squared, especially on the outsides, on the ends of the graph. The middle part's going to look a little different, but the ends of the graph will always be thinking like x squared. All right, and if it's an odd degree, x to the third, x to the fifth, x to the seventh, that kind of thing. Then in that case, we're going back to something linear. So in that case, you got to think about slope. Okay, so here's where we need to go back in our Wayback Machines, back about a week ago when we were graphing on the test. What happened if we were graphing x squared and the coefficient with x squared was positive? What did the graph look like? Or somebody said it was up, right? So that was where it looked something like this, right? Okay, so every graph that we have is all going to be similar to this one. So all you're going to do on this case is there's going to be an L and an R, or sometimes they're just going to have you put it in order. So the left is going to be up and the right side is going to be up. Or you can just say up and up. Okay. And what about if x squared was negative? What if it was negative 2x squared? What would the graph look like? Yeah, the downward graph, right? Something like that. So in that case, the left side was going to go down, and the right side was also going to go down. So positive x to the second, x to the fourth, x to the sixth, it's both sides are up. If it's negative, then both sides are down. Okay, so again, we're going to go left and right on these. If it's and again, we're thinking slope in this case. What if it's a positive slope? What does the graph do? Which side's up, which side's down? There you go. Left side is down, and the right side is up, so this one's down up. Okay, and then if it's a negative slope, it's just the opposite, correct? The left side is up, and then the right side is down. Okay, so when we're doing these examples, That is that's your four choices. It's either up, down, down, or up, down. All right, so here we go. Here's one example to look like. And these are all really short because there's not a long answer that goes with it. Okay, and the only this one I don't when you're getting in behavior, there shouldn't be. I don't think there's anything else where it's going to ask you to write it in standard form. It's not going to ask you for the number of terms. It's pretty much just going to be a question of okay, what is the end behavior here in this case? And which is the good thing is for that part of it, all you have to do is find your highest power of x in this case. So for that part, that would be your x to the fifth, which is this term. That would be your leading term. That's your leading coefficient for this thing. And all you got to look at it is this. Okay, if that's going to be my leading coefficient, I got to know that this thing is a positive x to an odd power. So if it's a positive x to an odd power, that means we're going positive here. It's a odd power here. So the answer is just going to be down, up. Okay. And again, it should be a drop down menu where it's just got one of those four choices, or it's got a drop down on the left for your left side and they drop down on the right for the right side, and you just pick those two things, whatever's there. All right, so just a different one here. Negative 4x squared plus 3x and then minus 8x to the fourth plus 17. Okay. Again, if they ask you to rewrite it in standard form and name the terms and the degree, all that stuff in this case, but just simply ask for in behavior, all you need is what would be the first term in order if we were to put this thing in standard form. That's the negative 8x to the fourth. Okay, and again, all you need from the leading term is two things. First off, is it positive or negative? It's negative. And then it's x to an even or odd power. That's even power. Okay, so negative x to an even power puts us here. So down, down.